So far we studied the set builder notation, union and intersection of sets, and interval notation. Suppose we have set A equals the set of x such that x is less than or equal to 2, and set B equals the set of x such that x is greater than 3, and we asked you to find set called S, which is set A union set B. We would like to find what is S, which is A union B. In this case, set A first, and second we will graph set B, and third we will graph set S. Set A 1, 2, so it is closed at 2, and x is less than 2 closed. So from 2 closed, from negative infinity up to 2 closed. Graphing B, x is greater than 3 open, so it is from 3 open to infinity. So if we'd like to graph what is S, it is the union of A here to 2 closed and B here to 3 open. So all these areas represent S. So what is S? It should be from negative infinity to 2 and from 3 to positive infinity, from 3 open of course to positive infinity. Again, S equals the set of x. S equals A union B. What is A? A is the set of x such that x is less than or equal to 2. Union B, the set of x such that x is greater than 3. This can be written differently also in the interval notation. Here it is the set builder notation. We can write it in the interval notation as follows. You just represent this, which is S. In the interval notation, we write it as from negative infinity open to 2 closed union 3 open to infinity. If I give you an example to graph this set, which is the set of x here x such that x is greater than minus 4 union the set of x such that x is less than 1. I want you to graph this set. Let's call it set S. First, we take this one, this set, which is the set of x such that x is greater than minus 4. It is graphed like this. 0, minus 1, minus 2, minus 3, minus 4. So it is open here. X is greater, so it comes from here to infinity. Okay, and then we graph this set, which is the set of x such that x is less than 1. Here 0, here 1. Open. X is less than 1, so it is from negative infinity up to 1. So the union of these two sets is graphed like this. Here we have 0. So we know what is the union. We take all the values here up to the open minus 4 and here from negative infinity to 1 open. So what is S, or what is the union of them? We can say simply it is from negative infinity to positive infinity. That is, it will take all the values, even this, the open one, because here it is closed. It is the set of real numbers that are either greater than minus 4 or less than 1. If I change the example here and I tell you to find not the union, the intersection. So what is the intersection of these two sets? We have to see where those two sets intersect. So take here, from here, therefore we can see from the graph that they are intersecting in this portion and in this portion. Or let me graph it here again. So we are having the first set here 0 up to here minus 1, minus 2, minus 3, minus 4. Here open 4. Okay. The second set is 0, here 1. Okay. So here it is open. Here it's going to positive infinity. And here it's going to negative infinity. All of them are open. The intersection is going through this portion up to here. They intersect here. Where do they intersect? They intersect from minus 4 to 1. Of course, minus 4 open to 1 open. If you represent it in the graph, it would be like this. Here 0, minus 1, minus 2, minus 3, minus 4. Open to up to 1, of course. Open. So this is the intersection of the two sets. Before, we solved the union, provided us with negative infinity to infinity. However, the intersection is like this graphed. This is the interval notation. This is the interval notation. Here interval notation, interval notation, and here of course set builder notation. The set builder notation here also can be written, or this interval can be written in a different set builder notation like this. It is the set of x such that x is greater than minus 4 and x is less than 1. Let's take an example. Graph the following, which is a the set of x such that x is less than or equal to minus 1 union x, the set of x such that x is greater than or equal to 2. Okay, the answer of this question is that we first take this and represent it in graph. So it is here 0, here minus 1. X is less than or equal to 1, so it is here closed, and it is coming from negative infinity. Now take this one and also graph it. I mean the second set. So we have 1, 2. So here it is 2, also closed, and x is greater, so it is coming to this. So the union, we take all the values. We take all the values here and here. We take all the values, then the answer, our answer should be, if we write it here, our answer should be 0, so it is here minus 1 closed, and here 1, 2, here 2 closed. This is our answer. You can represent it in interval notation as it is from negative infinity to minus 1 closed union 2 closed to infinity. Another question, the set of x such that another question, the set of x such that x is greater than or equal to minus 1 intersection with the set of x such that x is less than 5. So we take, let's call this A, okay, and let's call this B, and we have to find the union. This is set A, this is set B. So A, if we graph A, 0, minus 1, minus 1 closed, so x is greater than or equal to minus 1 in this area. B, x is less than 5 open, so 5 open, then we are going this way. So where do these two sets intersect? They intersect from here, close minus 1, 5 open. So when we represent them, it should be, of course, here 0, should be from minus 1 closed up to 5 open. Okay, this is the area. This is the area. It is from minus 1 to 5 open. This is the intersection of these two sets. The interval from negative infinity to 0 union 1 to 3 closed. So answering this, 0, here 0 open, and it is from negative infinity to 0. Okay, the second set, this is negative infinity to 0. The second set or interval from 1 to 3 closed. So graphing it, here we are saying 1, 2, 3. So if it is from 1 closed, 2, 3 closed. Where do they unify? Of course, this portion here up to 0 open, and from 1 closed to 3 closed. They do not intersect. They do not intersect. If I ask you, for example, another question, union 1 to 3, the answer should be an empty set or 5. They do not intersect. They do not intersect. There is no intersection between the two sets. These two sets, this comes from negative infinity to 0 and stops, and we jump from to 1 closed to 3 closed. So they do not intersect. There is no intersection here. Okay? Suppose I want to graph the intersection between these two sets. Here 0, here 1, 2, 3, 4, 5, 6, here minus 1, minus 2, minus 3, and minus 4 up to infinity. Let's graph this interval with blue and this interval with green. Okay, so the first interval, which is from minus 1 closed to 3 closed, so minus 1 closed up to 3 closed, here we have the set. Okay, the second interval, it is from 1 open to 5 open, so we are having this set. Okay, the intersection of these two sets lies here, this area here, from here to here. Here we have the intersection. Okay, where do they intersect? They intersect in 1 open up to 3 closed. They intersect in that. If you put 1 closed to 3 closed, this is wrong. Why? because one closed only here. In this set, it is not closed. They should be closed in both sets or both intervals. So we will remove this and say that the intersection is the intersection again here 0 minus 1 minus 2 1 2 3 from 1 open to 3 closed. We are done. The last example of this lecture. If I tell you to graph the union of two sets, the set of x such that x is greater than or equal to minus 3 less than 0 union the set of x such that x is greater than or equal to 2. So let's graph them together. I will put this one with blue and this one with green, and we will see what is the intersection. So here 0 minus 1 minus 2 minus 3 minus 4. So 1 2 3 4. The first set, it is x is between minus 3 closed and 0 open. Minus 3 closed and 0 open. Here x. Graphing another set, x is greater than or equal to number 2. So it is here closed and x is greater, so it is going like this. So the union of these two sets is simply as from minus 3 closed to 0 open, union from 2 closed to infinity. If question comes and ask what is the intersection, the answer is what? Phi, or what we call it the empty set or null. So the union of these two sets is here, and if it is asked again what is the intersection of these two sets, the answer is phi, that is the set of x in which x is greater than or equal to 3 less than 0 intersection with the set of x such that x is greater than 2 equals phi.